Hello everyone and welcome to this episode of Ask Roberto. We conducted a survey on social media reaching out to the NDI community to find out what topic you would like me to cover in this episode. So here I am, ready to dive into discussion about NDI and networking. First of all, it's important to share some key technical information about NDI. Over the year, NDI has evolved, adopting different transmission protocols, from TCP, then UDP, to multi-TCP, and finally, with NDI 5, we have adopted reliable UDP. Each of these protocols behave differently in your network and may require some minor fine-tuning in the network switch. First and foremost, it's crucial to highlight some key technical detail about NDI. So NDI as a default use unicast, making it straightforward to be implemented in a network. However, it's also possible to use NDI with multicast. For multicast functionality, you need to ensure that your network infrastructure supports it. Let's now clarify in a simple way the difference between unicast and multicast. Unicast video streaming is a type of digital data transmission that is quite straightforward to explain. Imagine you have a video you want to send over your local area network. In unicast streaming, this video is sent from one sender, like your computer or a video camera, to one receiver, like another computer or device. To simplify, unicast can be compared to a one-on-one conversation, much like a phone call, where you speak to a single person at a time. In unicast streaming, the video is transmitted to one specific device individually. Each time a new device tunes into the stream, the transmitter must create a separate stream. And this implies that every transmitter has a limited streaming capacity governed by the bandwidth availability of their network interface. Multicast video streaming is a bit like sending out invitation to a group event. So imagine you are organizing a party and you send out one invitation to a group of friends. Everyone in the group receive the same invitation at the same time. Think of it as a broadcast on television. When a TV station broadcasts a show, it sends out one signal up to a satellite, and anyone with a TV can tune into that channel and watch the show. They don't need individual signals sent to each TV. One signal is received by many. Multicast works in a very similar way over a network. One video stream is sent out and multiple devices on the network can access and view that stream without needing a separate stream from each device. In this scenario, the network switch acts like the satellite. Anyway, we will delve deeper into the topic of multicasting in future Ask Roberto event. Now, it's important to take in account the bitrate used by NDI, because NDI supports different video codec. H.264 and HAVC use low bandwidth, but NDI high bandwidth, which is based on the NDI proprietary codec SpeedHQ. With this codec, the bitrate can be very high. At 1080p60, the bitrate can be up to 132 megabits per second. For this reason, as you can imagine, a gigabit network infrastructure is mandatory. And now, cables. Because cable quality can significantly impact the real network speed and the packet loss. So we need to be aware about cable category, because Ethernet cables are categorized by their performance specification, such as category 5E, category 6, category 6E, category 7, and so on. For a gigabit network, category 5E is generally okay, but category 6 and above are recommended for better performance, especially over a longer distance or in an environment with potential interference. And now we need to talk about shielding, because shielded Ethernet cable, STP, are designed to reduce electromagnetic interference, which can be crucial in areas with a lot of electronic device. Because those interference can disrupt signal, reduce the network speed, generate packet loss. On top of this, it's very important to be aware about the connector quality, because the quality of the connector and how well they are terminated can also impact performance. Poor connection can lead to packet loss and slower speed. And then, if you use fiber, we need to know that there are two main categories of fiber, multi-mode and single mode. Multi-mode fiber are ideal for fixed system, but not really suitable for long distance. It's important to note that all the fiber used in broadcast equipment are based on single mode. Optical fiber are often more efficient than copper-based connection, but it is essential to consider that fiber connectors require much more attention than copper connector, because a dirty or damaged fiber connector is likely the reason for packet loss in your network and the experience of frame drops with NDI. In my personal experience, single-mode fiber is more reliable than multi-mode fiber, and in general, I prefer using fiber over copper, because the biggest advantage, aside from the increased connection length, is that the same fiber can transmit data in a different speed. So with the same fiber, you can do 1 gigabit or 10 gigabit and 100 gigabit. And this is very interesting, because you don't need to change the cable. It's always the same fiber. And now, the king of your network infrastructure, the network switch. Consider the network switch as a crucial game changer in your NDI experience. While various issues can arise during a live broadcast, and most of them can be fixed, and there is always some workaround, to create a successful show, a failing or inadequate network switch can lead into a complete disaster in your production experience. So, the golden rules for choosing your network switch are: first, choose a layer 2 managed network switch. Stay away from cheap, unmanaged switch. And then, oversize it. If you think that 16 ports are sufficient, opt for a 24-port switch, preferably with some 10 gigabit port uplink. And then, very important, verify the switch capacity. So the network switch must handle a full wire speed traffic on all its ports simultaneously without causing any packet loss due to internal congestion. And so this is an excellent example of a network switch that meets good specification for NDI. An example, 48 gigabit port plus 4 10 gigabit SFP plus with a switching capacity of 176 gigabit per second. And so, considering that every port must support bidirectional traffic, known as a full duplex, here is a breakdown of the number. 48 gigabit port in full duplex means 96 gigabit per second. 10 gigabit ports in full duplex means 80 gigabit per second, which in total means 176 gigabit per second. And then the switch setting. There are mainly two important settings for NDI and in general for video over IP. jumbo frame and flow control. Jumbo frame, not the best frame for NDI. Jumbo frame in network switch refer to Ethernet frames that are larger than the standard 1500 byte. While there can be beneficial for certain types of data traffic by reducing overhead and improving efficiency, they are not typically recommended for video over IP transmission due to several reasons. First, compatibility issues. Not all the network equipment support jumbo frames, and in a mixed environment where some devices support jumbo frames and others do not, this can lead in compatibility issues. The other point is fragmentation. If a jumbo frames encounter a device that do not support its size, it needs to be fragmented into smaller frames. This fragmentation can introduce latency and reduce the performance benefit of using jumbo frame. And then buffering and processing overhead. Larger frames require more buffering and processing power in network device. In scenarios where switch or routers are not equipped to handle large frame efficiently, this can lead into increased processing time and buffering delays, which are problematic for real-time video transmission. And network congestion. So jumbo frame can hold more data, which means that if a frame is lost or corrupted, a larger amount of data is affected compared to a standard frame. So make sure the jumbo frame are disabled. Network switch flow control, both symmetric and asymmetric, is about managing the piece of data transmission between two devices to prevent packet loss due to network congestion. Flow control mechanisms are fundamental in situations where the rate of data transmission exceeds the receiver's capacity to process the data. A good example is when an NDI transmitter uses a 10 gigabit interface and a receiver is connected to a 1 gigabit network port. There are two ways to approach the flow control: symmetrical and asymmetrical. Symmetric is used in network where both devices might face congestion, and asymmetric is more common in scenarios where only the end device and not the switch are likely to be overwhelmed. Does NDI require flow control in network switch? This depends on the NDI version. NDI 5 use a reliable UDP as a transmission protocol, which itself is designed to handle aspects of congestion and flow control. And here how it works. Reliable UDP is an extension of the standard UDP protocol that adds features typically found in TCP, such as data packet order and delivering assurance, retransmission of lost packet, and flow and congestion control. And here are the main advantages of a reliable UDP. Ensure data packets are received in the order they were sent. Detect missing packet and request retransmission. Manage the rate of data transmission based on the receiver ability to process the incoming data, thus preventing buffer overflow. Adjust the data transmission rate in response to detected network congestion, minimizing the impact of packet loss and delay. Multi-TCP NDI4, UDP NDI3, and TCP NDI1 require flow control enabled. That said, if all your NDI devices are updated with NDI 5, you can avoid enabling flow control in your network. But many hardware devices like NDI encoders and PTZ camera are still using TCP, and in mixed environment where there are both 10 gigabit and 1 gigabit interface is a good practice to enable symmetrical flow control in your switch. Flow control mechanisms require a network switch to engage in additional processing, memory allocation, and network traffic analysis, which consume its resource. Another very good reason to oversize your network switch for NDI. And now, few other more tips. Quality of service is not needed anymore with modern network infrastructure based on gigabit or 10 gigabit. And then, very important, test your workflow before your event. This is very important. Even if you know that in theory all your network setup is fully compliant with NDI, it is always a good idea to simulate your event before being live. Debugging before is a very good practice. And this is a good checklist for your live production with NDI. So, are your cable or optical fiber good for NDI? Is your network switch a layer 2 or layer 3 managed? Is the network switch capacity okay? And then, are the unicast NDI stream not exceeding the sender network interface capacity? And at the end, is your workflow not exceeding the receiver network interface capacity? That's all for today. And don't forget to visit our website, ndi.video, especially the documentation section. We constantly update our documentation and we share a lot of useful information. So, time for the Q&A session. How can I help? And we have already some questions. The first question is very interesting. If you are receiving about 700 megabit per second on NDI and sending 100 megabit per second, is worth using 2.5 gigabit card, or it makes sense to move to 10 gigabit. So the 2.5 gigabit card are working very well. The only thing is limited compatibility. Not all network switch support 2.5 gigabit. So 10 gigabit is much more like a standard. And but I mean, you can use, of course, 2.5 gigabit. The other question is when we are going to see NDI with 10 bit and HDR. Very soon. I mean, NDI 6 is coming. Most probably beginning of next year. R&D is working hard to make it happen, and so we'll see it soon. Then what USB-C to Ethernet adapter do you recommend? I tested a lot of USB-C to Ethernet adapter. I never found any problem, so feel free to use it. So I don't see other question. Let's see if some question is coming. Or we end up the session. So Victoria, my colleague Victoria is sending me other question in our chat. Let's see, something is coming. Okay, so how does NDI router route signal? Does this direct signal? Oh, I'm not sure I completely understand the question. If I understand, I can route NDI in different subnet if this is the question. So compared to other video over IP technology, NDI is very simple. There are different ways to do it. For example, with NDI Access Manager in any computer, you can select, you can define source IP address when are outside your local area network. Or you can use multiple discovery server. To have more information about this, just look in our website in the documentation section. So if an NDI camera is on the network, is still using up the bandwidth, even if not receive, no. So NDI sender is sending only discover information, so very small amount of data, until is connected to a receiver. And so there is no video sent from any NDI sender if it's not connected to a receiver. So IGMP snooping. This is a good question. If you want to use a multicast, you must enable IGMP snooping. If not, there is no need to do it. So NDI bridge. So yes, I mean NDI bridge is a good solution to increase the number of output in unicast. For example, I have a NDI high bandwidth camera, and I want to share this output to many receivers. A number of receivers that exceed the sender capacity. And this is where NDI bridge is very useful, because I can use NDI bridge in local mode, and at this point I can transcode from NDI high bandwidth to NDI HX with lower bit rate. And then at this point I can keep using NDI in unicast, but I use this bridge machine as a repeater, let's say. So the best practice for effectively using NDI HX camera on iOS and Android in this stage. So if I don't think we have any solution to receive an NDI HX, but we have an NDI HX application to use an iOS or Android to stream. So just go to, look in the marketplace in iOS and Android for a HX camera. So I have zero issues running full NDI in my network, but when I use NDI local bridge, it crashes after 30 minutes or so. So, this is very strange. You should, first you should make sure that you have the last version of NDI tools, 5.6. If you still have this problem, contact our support. So are isolated VLAN recommended to improve NDI performance? Yes and no, depend how big is your network, and how busy is your network, and how many technology you use over your network. So for example, if you use NDI with some other audio over IP like Dante, there are ways to make Dante and NDI working fine in the same local area network. But if you don't want to have issues, probably having two different VLAN is better. And then you have to consider the amount of bandwidth you are using in your local area network with NDI. So, sometimes the bandwidth you need is very high, and so is making the network very busy. And so why not having maybe a different VLAN to do other workflow? So could you share what the lowest latency you have experienced between camera and something like TriCaster or vMix? So yes, sure. First of all, depend of the format or of the codec. So usually NDI high bandwidth is faster than NDI HX. Right now, and with NDI HX3, the latency is very close to NDI bandwidth because we define it. And all the HX3 product must be tested and approved by us. So my experience, let's talk about glass-to-glass latency. So I have an NDI camera, and then I have a monitor, and I want to see how many frames I'm losing on glass-to-glass. First of all, we need to take in account that many cameras introduce a lot of delay. Because they do a lot of processing. For example, PTZ camera, many PTZ camera introduce maybe 2 or 3 frames of delay. Broadcast camera, of course, probably introduce 1 frame. And so in my experience, what I tested, I can tell you that glass-to-glass latency with NDI bandwidth is around 3 frames when we work with NDI bandwidth, and probably 4 frames, depend of the camera again, if we work with NDI HX3, sorry. So NDI HX can be higher because usually the processing of camera that support NDI HX are bigger, more, there is much more processing, and the encoding processor is lower. Okay, so do you recommend power cycling server and switching every so often to refresh? No, I don't. I mean, we have users like broadcaster that their network infrastructure is on 24/7, so I don't think it's needed. Oh, another information about latency. Usually, TriCaster pass-through the latency is less than 2 frames. And this is very interesting. So as a software application, if you do NDI in, NDI out, in PAL, 50 frames per second, the test I've been doing shows something like 30 milliseconds of latency, so less than 2 frames. How do I measure the bandwidth, I guess? How do I measure the BW, the bandwidth? Oh, I don't think you need to measure. I mean, just go on the website, and we have all the documentation. They show all the bandwidth used by NDI per resolution and frame rate. And so it's much easier. So if you have one camera sending NDI bandwidth, the maximum bitrate at 60p is around 130 megabits per second. If it's sending 2 streams, then it's double. Okay, so how well do NDI and Dante coexist? What about Dante AV? Oh, okay. NDI and Dante audio coexist very well if NDI is using reliable UDP, NDI5. And so especially if you have a software application like, I don't know, TriCaster, vMix, OBS Studio. So usually is the NDI output of an application that is creating issue especially in the synchronization with Dante audio. And so if you use a system that is, or an application that can use NDI5 and output reliable UDP, most probably you will not have any issue making NDI and Dante using the same network interface. Is a good idea to enable flow control in the network switch anyway. Regarding Dante AV, I don't have any experience having Dante AV and NDI working together in the same network, but this is a good question. I will try to do some tests. So in a multi-site production, what are the pros and cons of using NDI bridge over an enterprise network? Okay, I mean, there are many benefits, especially, again, if you are using NDI high bandwidth source. I mean, a good example is I'm doing some production like webinar or whatever, and I'm using NDI high bandwidth. And then I want to share few cameras and source to other group doing other production, other event, but I don't want to use the full NDI high bandwidth stream over maybe a single gigabit connection that interconnect two different infrastructure. And this is where NDI bridge can be very useful. And so consider that you can use bridge in join and host mode even in a local area network, and this is really useful because then you can really multiplex multiple NDI compressor stream over a single transmission. They keep the original synchronization, and so on the join mode, I mean, you discover all the device in the host mode and vice versa, but the amount of bandwidth used in this point-to-point connection is much lower than sharing NDI bandwidth. So how do big broadcaster implement failover over NDI senior? What is the best practice? So consider that in NDI, we don't have the same failover available in SMPTE 2110. The best practice is making pure networking failover. But with NDI is not seamless. And so broadcasters are happy with that. And more and more we see broadcasters using NDI in video production, in live video production for different events. And so, of course, there is a difference, and NDI do not support seamless failover. Is it correct that when you use TriCaster, full NDI bandwidth is only used when input goes live, but when using OBS or vMix, all input are full NDI? Yes, that's correct. So NDI, any NDI sender can send two different streams, let's say the full stream and the proxy. And you can see even those numbers in the documentation section on the NDI website. So there are some applications like TriCaster that are able to use this technique. I mean, all the sources that are actively used in an output or in an overlay are received using the full bandwidth. And all the input that are in preview or in the multi-view are proxy. And this is the reason why an application like TriCaster or Vector Plus can support many more sources simultaneously compared to other software like OBS or vMix. Oh, many questions. I'm happy about it. Let's see, Victoria is typing another question. Thank you, Victoria. So, do you know of any NDI converter that can do encoding and decoding at the same time? Oh, this is a good question. I'm not aware about any hardware-based encoder, but for sure, you can do it by software. And a good example is if you use a computer with an I/O card, SDI multi-channel I/O card, and you use Network Connect Pro, then you can build your own bidirectional encoder. And I mean, there are advantages to have a computer instead of hardware encoder. And so this is probably a good solution. So how powerful of a machine do you recommend for NDI bridge, graphic card? Oh, this is a very good question. Okay. NDI bridge use a GPU for transcoding. And so you need to have a GPU that support encoding. So gaming GPU are usually limited by the number of simultaneous encoding. If I remember well, are 3 simultaneous encoding. If you go to high-end GPU or like Quadro, I don't think, there is no this limitation. The only limitation is, I mean, the amount of simultaneous encoding the card can do it, but it's not limited by the manufacturer. Intel GPU do not have this limitation, but again, the amount of simultaneous encoding and decoding you can do with NDI bridge depend of the GPU capacity. Okay, it is best practice to have a network card which is dedicated to NDI and use the onboard card for internet only. I don't think so. I mean, internet traffic is so low. And again, depend of how complex is your production. I mean, in a normal production with even several cameras, you don't need to have a different network interface for do that. When will all NDI applications be available on macOS? Oh, this is one of our, I hope soon. I mean, it's a big effort. There are applications that most probably, like NDI bridge, cannot be ported on Mac for architecture reason. But we are working on that and something will happen soon. So I don't see any more question. Oh, it's over 1 hour. So I think we can end up this session. I thank you so much, for being part of this event. I thank you so much for sending so many questions. And see you soon in the next Ask Roberto episode. And have a good Christmas. Bye-bye.